So again, we're looking at the introduction, and Terrell received a gift card for $20 of music downloads. If each download costs 89 cents, the number of downloads he can purchase can be represented by the inequality. So this inequality just represents what you just heard. We're looking at solving inequalities by multiplication and division. That's chapter 5, section 2. And as always, we want to start with kind of getting our head around what and how we use this regularly. So take a moment to pause the video and think about these questions. So in the inequality 0.89d is less than 20, what does the variable d represent? Well, it represents the number of music downloads he can have. And why is the inequality symbol less than or equal to used to represent the situation? Well, Terrell has $20 to spend. So the cost of the music downloads has to be less than or equal to the amount of money he has, which is $20. What operation can you perform to get the variable on one side of the inequality? Well, since the variable's on the left, and the only thing that's attached to the variable is 0.89, since attached things in math are multiplication, we want to do the multiplicative inverse, which is basically going to look like division. So we're going to divide each side by 0.89. Okay, so first we want to look at just what happens when we have inequalities. So when we have an inequality and we actually do multiplication or division by a positive, we get this. So if I have 4 is greater than 2, and then I multiply both sides by 3, on the left I'm going to get 12, on the right I'm going to get 6, and 12 is greater than 6. So this inequality sign, facing the way that it does, is preserved by multiplication by a positive. If we look at now multiplication, and we look at now division, okay, what we're going to see is that even if we have negative numbers, but we decide that we're going to divide both sides by 5, well, division on both sides will give me negative 2 on the left, negative 1 on the right. And so, again, the inequality is preserved. Remember, even though we started out with negative numbers, this says divide each side by 5. And dividing by 5, since 5 is a positive number, our inequality sign is still facing the same way. It's still preserved in the way that it's going. Just like addition and subtraction, it's preserved for multiplication and division for positives. Where we run into some change is when we look at negatives. So if we have 7 and 9, 7 is less than 9. If I multiply both sides by a negative, I'm going to end up with negative 14 and negative 18. Well, if we remember our number line, negative 14 is over here, negative 18 is over here. So what we notice is when we multiply both sides by a negative, our inequality sign is actually not preserved. It's actually flipped. And that's why we write it this way. So if we remember our number line, that's what it would look like. Bigger numbers go to the right. And that was multiplication. We're going to look at division. And guess what? Same thing happens. We start out with 15 is less than 18. And we divide both sides by minus 3. We should end up with minus 5 on the left, minus 6 on the right. So now when we do that, remember our number line again. Minus 5 is over here. Minus 6 is over here. So we have to flip our inequality to get that preservation of truth. Okay? We need to have a true statement when we go through this. And if it's not a true statement, then we haven't correctly preserved or used our inequality sign. So division or multiplication by a negative number. And remember this by, it's what you're moving, what you're doing as opposed to what's sitting there. That by is the thing that gets changed. So we're going to look at a word problem first. So the Jefferson Band boosters raised more than, okay, and as I read through, I like to underline or highlight things, more than $5,500 from sales of their $15 band DVD. Define a variable, write an inequality to represent the number of DVDs that they sold. Solve the inequality and interpret your solutions. So they made $5,500. Right? But they made more than $5,500. So if they made more than $5,500, the thing we're talking about, the amount they raised, is more than $5,500. Well, how did they raise this money? Well, they took $15 for every DVD. Well, what have I forgotten to do here? I've forgotten to define my variable. So I'm going to do that. D is going to be the number, so let D be the number of DVDs. And that should make sense, because if I take the number of DVDs, okay, if I take the number of DVDs and I multiply it by 15, that gives me how much money you make. And since they say that they raised more than, it's not or equal to, it's just more than, it's not a ceiling, or it's more than $5,500, this is what I end up with. So now, I've done the first part, I defined my variable. I did the second part, I've written an inequality to represent the number of DVDs they sold, okay? And then I'm going to solve this inequality and interpret my solution. So I'm going to divide by 15 on both sides, because I have currently a multiplication, and the opposite of that would be division, also multiplying by its multiplicative inverse. These two cancel to give you 1 when you divide, and so 1D is going to be greater than 5,500 divided by 15. And so we have 5,500 divided by 15, and that's going to give us 366.6 bar DVDs. Now, remember what this number means. I'm going to write it in set notation just as a reminder. D is the variable we used, such that D is greater than 366.6 bar, fancy brackets. Now we have to actually interpret our solution. That's the last part of the problem. We want to make sure we answer all of the questions, all of what the question is asking. So clearly, since 5,500 is the least that they can make, because they made more than that, we would interpret this solution as the band made more than, or sold, not made, sold more than 366 CDs. That's clear from what we're seeing here. Why did I leave off the decimal place? Well, you can't sell 0.6 of a CD. You can't chop it into 3 pieces and put 2 pieces back together and sell that to somebody. So they definitely, actually, should be not 366, but 367. They definitely sold 367 or more. So we have to round up because of the context of the problem. So now we're just using our skills. Before we were trying to interpret the word problem, now we're using our skills to solve this. So solve each inequality, graph the solution on the number line. A tip, when we have fractions, it's easier to do multiplication because you can to separate and to solve. And when you have whole numbers, it's usually easier to, when you have whole numbers or integers, it's usually easier to do division. So we have a fraction here. The fraction is being multiplied. Instead of dividing by the fraction, we just multiply by its multiplicative inverse. Okay? So the multiplicative inverse of 1/2 is 2/1. This isn't here. And then when we do that, we get 60 on one side is greater than, 2 cancels 2, 1 cancels 1, n. Okay? We're back to our electric fence. So we have 60, we'll put that in the middle. We're going to put an open circle. N, the numbers that we're talking about for n right here, are less than 60, because 60 is greater than n. If you read from left to right, read from right to left, n is less than 60. So what we're going to do is we're going to draw an arrow to the left. okay? Because we're talking about numbers that are smaller than 60, because n represents all the numbers are smaller than 60. In set builder notation, we use our fancy bracket. N is the variable we're using, such that n is less than 60. You could have written it the way up there, but I wanted to write it in the other direction. It doesn't really matter. Okay? You need to understand that both this and this are the same thing, as long as the alligator eats the bigger number in both cases and it's the same number. We move on to these types of problems. So this type of problem, we have a whole number or an integer, as we talked about, as I mentioned before. We're going to use that to our advantage to recognize that we probably want to divide this first. So we're going to divide by 9 on both sides. We get t is greater than 12. Nope, yes, 12. And now we set builder notation. T is the variable such that, this is what I'm talking about, t is greater than 12. Put my boundary down. Again, it's an electric fence because there's no or equal to. Open circle. I'm going to put it on the line for those of you that like to put it on the line. And then I'm talking about numbers that are greater than 12 because t is greater than 12. Numbers that are greater than 12, go to the right. Again, we're starting out with this problem. Now we have a negative on the left, and, we have a negative on the right, and a positive attached to our variable. So the thing we're going to move is the positive. And because it's a fraction, we probably want to use the multiplicative inverse to get rid of it. So we're going to multiply both sides by 1 over 4. And when we do that, 4 cancels 4, 1 cancels 1. We end up with m is less than, when we multiply a whole number by a fraction, we multiply straight across. So negative 17 times 4 is negative 68. Now that we have this, notice I didn't flip my inequality sign because I wasn't multiplying by a negative. I was moving a positive number, and that's why I still have my inequality sign preserved. Again, this one is not an electric fence, it's a fence we can touch. Minus 68. It's a closed circle because that's the or equal to part. Since m is less than minus 68, less than numbers go to the left. And I've done that. Then, if I write it in set builder notation, I would have m, which is the variable I've chosen, such that m is less than or equal to negative 68. Again, now, this one's a little bit trickier. We kind of have a fraction, we kind of have an integer. Okay, so what we want to do is we want to look at it and kind of say it in a simple way. We're dividing by 34. And I'm actually going to take the negative and put it on the 34 as opposed to on my variable because I want to end up with a positive variable when I solve. So what I really want to look at is I have minus 2 is greater than or equal to d over minus 34. I'm going to multiply both sides by negative 34 to get rid of the division by negative 34. And then I'm going to get a negative times a negative is a positive. I'm going to get 68. No, all answers are not 68. These two cancel, but remember what happens for us. Since I'm multiplying both sides by a negative, I'm moving the negative 34, I must now flip my inequality sign to preserve the truth. Okay? Remember what we did in the beginning. We have to preserve the truth. And when we multiply both sides by a negative, we actually have to flip the way the inequality sign is going. I now end up with d is greater than or equal to 68, or read the other way, 68 is less than or equal to d. I have my 68. This is an or equal to, that's a closed circle because that's a fence I can touch. The d is greater than numbers go to the right. Okay, set builder notation would be d, the variable I've chosen, such that d is greater than or equal to 68. Again, I don't have to write it in that way, but you need to recognize that it goes in both directions. Continuing on, this is a problem we probably want to divide for, but now we're dividing by a negative. And so these negatives cancel to give you d. Because I'm dividing by a negative, I need to flip my inequality sign to preserve truth. I have 5 divided by negative 2, which is going to give me a negative 2.5, or 2.5. In this case, you'd probably want to convert it to a decimal because decimals are easier to graph. Again, I'm going to preserve what I'm talking about, but in this case, I'm not going to put down negative 2.5, I'm going to put down negative 2 and negative 3, because that's where negative 2.5 lies, halfway in between. And so now I'm going to put a open circle, because it's an electric fence, we can't touch it, but we have to know what the boundary is. We're talking about letters, not letters, we're talking about numbers that are greater than negative 2.5. Greater than numbers are to the right. My arrow goes to the right to represent where the numbers are. Okay, set builder notation. I have d as the variable. D is greater than negative 2.5. Okay, we're back to a word problem again. So the National Honor Society at Pleasantville High School wants to raise at least $500. So again, at least, we need to look at our context clues for a local charity. Each student earns 50 cents for every quarter of a mile. Okay, that's going to become important later on. How many miles will the student need to walk? So they're asking you how many miles, but they're giving you part of the problem as quarters of a mile. Okay, so it's very important to understand what we're talking about. So what I'm going to do is do what we've done before. I'm going to define my variable. So let x be the number of miles. And so since I'm letting x be the number of miles, I'm going to use x when I write down my inequality. We're back to at least, and at least is a minimum, right? You want to raise more money for charity, so there's a goal that you want to reach, but since it's a goal for a charity, you want to go above that. So at least would be a minimum. So we have 500 as the at least, which we want things to be greater than or equal to 500. And so now we have to put some stuff together. It's 0.5 for every quarter mile. So if it's quarter mile that I run, that would be a quarter of x, since I defined x as the number of miles. And this is where defining your variable becomes very important. It's a quarter x for every time I'm talking about. So I get 50 cents for every 1/4 of x. Or if I just write x, and then instead of writing 50 cents, because I get 50 cents for every quarter mile, how many quarter miles in a mile? 4 of them. If I multiply 50 cents by 4, I get $2. And so I now get $2 for every mile that I run. So now I don't have to put the fraction in my equation, in my inequality. I can put the $2. And so if I do $2 for every mile, which is 500, makes my life a little bit easier when I'm trying to solve. So that's where this goes, up there. I could just as easily have written that I have 1/4 x times 0.5. Okay, so I would have a quarter mile and I would get 0.5. And that would give me the 50, and then I would multiply that out. But it seems more efficient to use our whole numbers and put it together that way. Either way is fine. So I have 2x is greater than or equal to 50. I divide by 2. I get x is greater than or equal to $250. Okay? And it's not dollars, because what did I define x as? And this is a very important thing to see that I made that mistake. I defined x as the number of miles. So this is not dollars, this is the number of miles. Because my x is, right, this 2 is really $2 per mile. That's important to recognize. This is $2 per mile. So don't make the mistake that I just made. It's $2 per mile, so the x that I found is miles, is in miles. If I looked back at my let statement, which is over here, I would have recognized that I couldn't have put that $sign on the 250. So now I've basically said how many miles will the students need to walk? They need to walk a minimum. Okay, so need to walk at least 250 miles. It sounds like a lot, but remember this is a charity and those miles add up. Many hands make light work. Thank you guys, and I'll see you tomorrow.